Yeah, that splotch here. So it's really probing basically the earliest structures we know in the universe.
When you look at this image, there are lots of splodges all over the place. What made you look at that one in particular?
We have been seeing this object already in the very early data we obtained nearly 2 years ago. And I think the surprising thing was that it's actually very bright. And so our initial reaction was that, well, it cannot be that distant because it's too bright. And so we took better data, and in particular, we also took spectroscopy. We could clearly see that, no, that galaxy, that this yellow blob here, is really this most distant galaxy that we have ever seen.
Something very strange is happening in the early universe, and scientists have no clue why their theories are failing to explain these strange mysteries. Scientists are finding thousands of strange objects in deep field images, and they have no idea what exactly they are looking at. Recently, astronomers have discovered many strange objects in the early universe, and they said that these are not galaxies because these objects are completely different compared to early galaxies. In addition, the Webb telescope looked deep into the universe beyond the Dark Ages for the first time, and what it found has astonished astronomers. Most scientists agree that the universe began about 13.8 billion years ago. However, the strange structures revealed in these images challenge this timeline and could lead to major shifts in cosmology. In light of these groundbreaking observations, several Nobel laureates suggest that the early universe might be vastly different from what we thought. Some even propose the radical idea that the universe may not have had a beginning at all. Instead, they speculate that the distant universe which we are considering as the early universe may actually be something else about which we have no idea.
Lambda CDM of cold dark matter and the dark energy that everybody considers a standard. According to that model, some of these objects they're seeing from the early universe are too massive. They'd have too many stars in them. It doesn't make
time to become that massive.
Well,
that had
all
to be,
all of the ordinary matter of the universe would have had to go into these things, and that just doesn't make sense. You don't have enough ordinary matter to produce that many stars.
So, what did the James Webb telescope just see at the very edge of our universe? And why are scientists claiming these discoveries could change everything? In 1921, scientists discovered that our universe is expanding by observing the movement of galaxies. However, the expansion of the universe isn't as straightforward as it sounds. Let's break it down with a simple analogy. Imagine a blank sheet of paper that stretches infinitely in all directions. This sheet represents the fabric of space. When scientists say the universe is expanding, they actually mean that this fabric of space is stretching and growing. Now, to understand how this expansion works, imagine placing two galaxies on this expanding space. As the space stretches, you'll notice that the galaxies are moving away from each other. Now, it might seem like this expansion is happening from a specific center point, but that's not how it works. Let's place a third galaxy somewhere else on the paper. You'll see that all three galaxies are moving away from each other. This tells us there's no single center where the expansion starts. In fact, no matter where you stand in the universe, it will always look like you're at the center because everything else seems to be moving away from you. It's the nature of the expansion. Every point in space is stretching. Scientists also observe that the farther away a galaxy is from us, the faster it seems to be moving away. This indicates that space is not only expanding, but its expansion is accelerating. It means for every 3.26 million light years you go out in space, things seem to be moving 70 kilometers per second faster away from us. Scientists have found that if we consider our Earth as the center of the universe, you will see at particular distance from us, space is expanding faster than the speed of light. And galaxies beyond that region of space are moving along the expanding space at a speed faster than light. But don't worry, this doesn't break Einstein's famous rule that nothing can travel faster than light. Einstein's rule applies to objects moving through space, not space itself. What's happening here is that space itself is expanding faster than light, which is perfectly fine according to the laws of physics. For centuries, we humans have been observing the universe with telescopes, and everything that we humans have ever seen in the universe exists inside this region known as the Hubble sphere, which is about 48 billion light-years in diameter. All the most distant galaxies we have discovered till date exist within this region of space. Galaxies within this sphere are still moving away from us, but at a speed slower than light. So, their light is still able to reach us, and some light from galaxies beyond the Hubble sphere started traveling toward us billions of years ago and will eventually reach us. This means that the Hubble sphere is gradually expanding, allowing us to see farther into the universe over time. But the Hubble sphere won't expand forever. This is because galaxies beyond a certain region of space are moving away so fast that their light will never reach us. This means that humans on Earth have a limit to how far we can see into the universe, and this boundary of the universe is called the observable universe. It is about 93 billion light-years across in diameter. There are many more galaxies and stars beyond the observable universe. We don't know how big the entire universe is. Most scientists believe that the entire universe may be infinite in size. Now, there is one more mystery that makes our universe even more strange. When we look at distant parts of the universe, we're actually looking back in time. We don't see those regions of space as they are right now, but rather as they were in the past. This happens because light takes time to travel through space. For example, if we look at something 1 light-year away, we're seeing it as it was 1 year ago. The farther we look, the further back in time we see. So far, scientists have observed more than 13 billion light-years into the early universe using powerful telescopes. And with the help of these observations, scientists have created a standard model of our universe, which shows what the universe looked like at different time periods in the past. Like, if you look more than 13 billion light-years away, then you will see the Dark Ages, which means that at this time, the whole universe was covered with dark clouds of hydrogen gas. According to the standard cosmological model, if we could look all the way to the edge of our observable universe about 13.8 billion light-years away, we would see the very first moment of our universe, the Big Bang. Scientists believe that at the very beginning, the entire universe was compressed into an incredibly tiny point called a singularity. We don't know exactly what this singularity looked like because our current scientific theories break down when trying to describe it. Just like the edge of the observable universe limits how far we can see in space, the Big Bang marks the limit of how far back we can see in time. Scientists believe that there is nothing beyond the Big Bang. Well, what we know so far is our basic understanding of the universe based on our decades of observations and theories. However, recent observations from the James Webb telescope have indicated that the Big Bang is not the beginning of everything after all. A strange universe existed even before the Big Bang, and new observations from the Webb telescope strongly support this idea. Take a look at this incredible image from the James Webb Space Telescope. It shows the light from a supernova that exploded 10.2 billion light-years away. What makes this image even more fascinating is that, due to a phenomenon called gravitational lensing, the same supernova appears in 3 different places at once. Scientists are studying this supernova to measure how fast the universe is expanding. Supernovae are one of the best tools for this, and they give us important clues about the universe's growth. However, the latest calculations from this supernova suggest that the universe is expanding faster than previously thought. In fact, this new measurement is so surprising that it hints the universe's expansion might have started even before the Big Bang. This idea is also supported by Nobel Laureate Dr. Roger Penrose, who believes that the expansion of space began even before the Big Bang.
The inflationary model says you get this inflation immediately after the Big Bang. I'm saying no, it was already there before the Big Bang. So the effects that look like an exponential expansion after the Big Bang are explained, I claim, by the presence of this exponential expansion, which is, in a sense, you look back through the Big Bang, and rather than having this inflationary phase after the Big Bang, it's actually before it.
This is not the only discovery suggesting that the universe existed in some form even before the Big Bang. Over time, scientists have gathered multiple pieces of evidence that strongly support this idea. The James Webb Space Telescope has been able to detect galaxies at previously unattainable distances. These galaxies have many properties that contradict predictions made by Big Bang proponents. Specifically, the galaxies are more abundant, more massive, more mature, more structured, higher metallicity, and exist at greater distances than predicted by standard secular cosmologies. One of the most startling discoveries by the Webb telescope was capturing a bright flash of light from beyond the so-called dark ages of the universe. According to the current cosmological model, we shouldn't be able to observe anything beyond this time period. Yet, Webb's observations defy this understanding, forcing scientists to reconsider some of the foundational principles of cosmology. The James Webb Telescope is continuously revealing strange phenomena near the beginning of our universe. These findings suggest that the Big Bang may not have been the absolute beginning of everything. For example, the discovery of unusual objects just a few 100 million years after the Big Bang indicates that the universe may have had a history before this event. Take a look at these 3 galaxies recently observed by the James Webb Telescope. One of these galaxies, called JADES GS-Z14, holds the record for one of the most distant galaxies ever discovered. This galaxy was observed only 290 million years after the Big Bang. Scientists are questioning how nature can create such a bright, massive, and large galaxy in less than 300 million years. They also said that it is likely that astronomers will find many such bright galaxies with the Webb telescope in the next decade, possibly even at earlier times. These discoveries have led scientists to confirm that some galaxies in the early universe formed so quickly that they challenge our current understanding.
According to that model, some of these objects they're seeing from the early universe are too massive. They'd have too many stars in them. It doesn't make
time to become that massive.
Well,
That had to
all
be
of
it,
the
right?
all of the ordinary matter of the universe would have had to go into these things, and that just doesn't make sense. You don't have enough ordinary matter to produce that many stars.
Some researchers now argue that our standard model of cosmology, which is largely based on the decades-old Big Bang theory, needs revision. The Big Bang theory traditionally suggests that nothing existed before the Big Bang, but recent findings from the Webb telescope challenge this view. There are signs that the universe may have existed in some form even before the Big Bang. Even renowned Nobel Prize-winning physicist Dr. Roger Penrose supports this idea. He has proposed a theory that suggests the universe existed in a previous aeon before the Big Bang. In a recent interview, Dr. Penrose revealed that we can imagine the universe extending beyond the Big Bang. To explain what he meant, he gave an interesting example, in which he mentioned a famous painting of angels and devils created by Dutch artist M.C. Escher.
So what you can do is you can represent infinity in this picture. That's a very nice representation.
You're representing infinity, but at a finite distance.
Yes, that's right. So you can make it in the picture as a finite distance. But as far as the devils and the angels themselves are concerned, they keep on going forever. And this is a geometry known as hyperbolic geometry. It's a very nice representation of infinity. I'm taking that picture as important in thinking about space-time, is that the Big Bang was like one of those Escher boundaries. But it's nice and smooth, and you can imagine that you could continue this universe to outside that region. So even though the Escher picture ends with this circular boundary, you could still imagine that the space-time continues out beyond that. So you could step outside it. Now the thing is, the angels and devils can't step outside that because they actually respect the the distance measure. So they know what distance is like. But what can step outside are photons.
These discoveries hint at the possibility of a universe that existed before the Big Bang. If proven true, it would forever reshape our understanding of the cosmos. That's all for today. If you enjoyed this video, be sure to share your thoughts on the exciting new findings from the James Webb Space Telescope.